Good morning, everyone. This is a test for to check the sound. If you could hear me, could you please send me a message on the chat? Good morning. Perfect. I have the message and you can hear me. So, good morning, everyone, and welcome to this presentation of the programs Box Culverts and the programs for the soil retention elements. During this presentation, we will know about the three different programs. These programs are among the structure family programs by CYPE engineers. We have here on my screen the side menu. So the programs that we will talk about on this presentation are the box culverts. We have also the embedded retaining walls, and we have also reinforced concrete cantilever walls. So we will start with the box culverts. Um, just as a remark, please, if you have comments, suggestions, or questions, you can share with us all these on the chat of the application. So let's start once again with the box culverts. So here we have the workspace. This is the first menu that appears, and it's showed to the user. So we will use for this presentation an example in order to show the different menus we have. We will also see different options and to talk about the workspace of the program. These examples are installed by default with the program, so it's a very interesting tool for the user. So, for example, in this case, you can see different examples. We will go to the example 8, and we can see on the workspace of the program the structure. We have a layout. For example, for this case, the model is obtaining using a template that could be an DXF or DWG file with all the necessary information in order to obtain the structure adapted to the project. So we can go to, for example, the 3D view. We can see that the structure is composed by different modules. In this case, we have 3 different modules with the main structure and the necessary elements as a wings, lateral wings. So we can see that the structure is completely adapted to the needs of the project. So how can we define a model in this program? We will start with an example defined from zero, from an empty project, and we will see the different steps necessary to define the structure. We will go to a new project. We, for example, and this is very interesting. The common point of the three programs that we will present today is the assistant. The assistant is a very interesting tool in order to define the necessary parameters for a project. So we will use for these three examples an assistant. So in this case, we can, for example, use the assistant for straight culverts, and the program will present us different menus in order to adapt the parameters of the initial project to our project. So here, for example, we start with the geometry. We have a drawing. We have also the menu in order to modify these parameters. For example, we have here, for example, the internal height, the clear span, the length axis. For example, here we will define a length axis different from the default values. We will define 10 meters for the length axis. We can go to the next step. Here we will define the geometry of the wing walls. We can define the wing walls with a projection extended angle or with a perpendicular angle from the principal direction. So in this case, we will define, for example, 25 degrees for the extended, and here, for example, also 35 and 30 degrees. Okay, so we can go to the next one, and here the user can modify the features and the parameters of the top roadway. So we have the drawing, we have the help in order to know what the parameters that we need to define. So we have the axis coordinate, this distance. We have also the possibility to define the angle, the width, and the height above bottom slab. We leave the default values for this menu. We can pass to the definition of the soils. Remember that this is only an assistance, and after to obtain the initial project, we can modify the values. For example, here we have the base type B. We can define, or we can choose from a drop-down menu with different soils. For example, here we can go to, for example, a semi-hard clay, and in the case of the infill type, we can, we will choose here a hard clay for the base, and the infill type we will define an semi-hard clay. We have the slope angle. It's interesting to know that the user, in the case of our programs in general, have a help on the screen. We have this remark, interrogation remark, and we can obtain help on the highlighted in blue parameters. And we can also obtain help on the screen in this icon with the figure of a book. And we have an interesting help in order to know what's the parameter that we are modifying or we need to define. So we can pass to the next one, loads. We will define two loads with the assistant, the track load, and we can also define the surcharge on the bottom slab. So here the generation type of the assistant can follow some of these codes. For example, we will define the RSI class and we can finish. Okay, we have, for example, here the slope angle with the type of soils we need to define as a maximum the 18 degrees. It's a remark that the program present us. So we can finish, and this is the data for the initial project. We can accept here, and we have our project. We can go, for example, for the geometry, and now the user can modify this geometry. So the first menu or the first interesting menu that the user need to know is here we have in this icon the configuration, and we will go to the codes. We have, for example, in this drop-down menu, the different codes that are available on the program. For example, here we will choose the American code. We can also change the units. Okay. We can modify, for example, the materials according with the code. Have so this drop-down menu, and important too, the grade or the steel grade of this for the reinforced bars. Other interesting menu is the general data. Remember that during the use of the assistant, we define the soils from a list with default values. But now the user have the possibility to modify the characteristics of the soils for the ground and the field with the values from an geotechnical test. That is the correct way to define the project. We can also modify the geometry, and for example, we can add an hydraulic surcharge here, checking this option, and for example, defining the depth. We can accept here, and we can go to the 3D view in order to see the surcharge defined with the option. Okay, this is the way to define a surcharge, hydraulic surcharge. So other interesting menu that the user can use in order to modify the initial data from obtained from the assistant. We can, for example, go to the plan. We can move, for example, a lateral weld point. We can, for example, apply displacement, okay? And we can modify, for example, an increment, in this case of -3, and for this one, also an increment of -3. So we have from the initial values, we had 10 meters. Now we have 13 meters. Other interesting tools is the possibility to edit the points of the geometry. We can move these elements. We can, for example, add a joint. Can go to plans and a new joint. As you can see now, we have two modules, and the reinforced bars will stop here. We can also, for example, move a lateral point there of this remark point of the geometry, for example. And we can go to the geometry, edit the module. We have the values of the thicknesses of the left lateral walls, to the right, to the left, of the top slab, the bottom slab. We can also add a division. For example, here we will define a thickness of 35 centimeters, and we can, in this case, we have 5 meters, and we will define 250 centimeters for the position of this division. We can see on the screen the position of the division that we add, and we can see on the 3D view how this division appears on the module. Okay, so in this case, I will erase the division. It's only as an example. And now so this is these are the different tools that we have in order to modify the geometry. I remember that we can also modify the geometry of the module, but of the wings too. So we can divide the wings in different intermediate sections, and we have so different options in order to adapt this wing to our needs. Okay, so until here, until now, the geometry. Now we will see the different loads. We can go to track loads, and remember that with the assistant we applied the R as a code. We can, for example, see here the different track loads applied by the program. But now we can, for example, modify the position of these loads. Okay, and we can also edit the track load, editing the position of the wells or modifying the load of every well too. The user can also create a new track load, adding the position of the wells and typing the value of the load of every well. If I want to, for example, apply other line of track loads, we can apply this manually, like that. Okay, so we have the 3 position of the track and the direction. So now we can go to the analysis. We can check, we can design all. In this case, we will design all the elements of the program, of this project. Sorry. So we have the different elements for this project. We have, for example, the possibility to go to the reinforcement. We can see the reinforced bars for the different element of the module 1, the bottom slab, the section. The user can, for example, modify the diameter of a bar, and for example, we can modifying these different values. We can check at the end the different elements, and we will have this report where the program show the different checks from the code. When we finish the edition and the analysis of the structure, we can go to this printer and obtain the report. So we have here this report that we can obtain it in different formats: PDF, docx, HTML, etc. We have the basics parameter of the project in order to communicate what's the initial values, the position of the loads, and the analysis method. We have an analysis from finite elements, and we have for every part of the modules the result for the forces and displacement for every load case. If we want to know about the forces, for example, we can see the modulus with the model from in this case, finite elements. We can see the form shape, the contour maps, we can see the maximum value, we can add the structure, and we can see, for example, the moments, shears, and axial forces too. And finally, we can also obtain the drawings. So all this information is obtained in drawings, layout. We can obtain all this in DXF or DWG format. And for example, I will show you the result of these drawings. Here we have the CAD program with all this information. We can obtain all this information in different layers, so it's easy to edit that or send to the plotter. We have as information, so the different slabs from the two modules. We have also the information of the wings, the section, the general geometry, and we have also the shape for the fabrication of the different reinforced bars. So for this program is not available the post-tension or pre-stress forces. We have only the passive reinforced bars.